Hi everybody. Today we're going to be talking about responsive images. Now, the old school way of providing an image on your website was to add an image element. You'd add a source attribute that had the URL to the image, and you would add an alt attribute that contained the fallback text for browsers that weren't able to display your image for whatever reason. And for many years this worked fine. You would measure the spot on your website where you need to display an image, and then you would cut an image to exactly that size, and then you'd drop it into that spot, and you could be confident that it would display at the correct size in the correct spot without causing any problems. But in today's world, we do responsive web design, and the spot that your image displays in may not always be the same size. It may be that the spot is smaller than the image asset that you provided, or it may be larger and you need a bigger asset. So how can we be sure that we're giving the browser the correct sized image for the place that it's displaying? Well, we can use a new attribute called srcset. So the first thing you'll notice here is that we're still providing a source attribute. That's going to be the fallback for browsers that don't get srcset. The nice thing about responsive images is they are 100% backwards compatible. This is a progressive enhancement technique where if a browser doesn't understand srcset, it'll just fall back to the original image URL that you've provided. So images will continue working as they work today. You're just layering some functionality on top for the modern browsers that understand. Now, you're also going to provide a srcset attribute. This srcset attribute contains a comma-separated array, a comma-separated list of images. You're going to provide image URLs, and you're going to tell the browser how wide each of those URLs are. And as a result of this, the browser is going to be able to pick the best possible asset from that list. And it is aware of whether or not it's a Retina device. So for example, if I'm on an iPhone that says it has a 320 screen, but it's a Retina screen, it will pick the 640 asset from this list. It's just smart enough to know how to do that. Now the next question you might have is, how do I know how many assets to provide? And it gets a little tricky. Here you can see that the actual image displays on the screen at 400 pixels. Providing an 800 pixel image and a 2000 pixel image might not be enough, right? Like that one is way too big and the other is Retina, but maybe you want to add a smaller one in between. Maybe you want to provide that 600 pixel image. Maybe you want to go even further and break it down dramatically. You can see here we've got a 400, a 450, a 500, a 600. The question here is, how much bandwidth are you actually saving your users? What I recommend is that you pick a standard image size array. Unless you're in a spot where you're hand customizing every single image tag, you're probably going to want to have a default set of, we provide images at these sizes. Obviously, this list should be customized for your particular use case. So for example, if your content well is 800 pixels wide, you might want to make sure 800 pixels is one of the assets that you provide. Now the next question is, how can we tell the browser what size our image is actually going to render at? Because what we've been discussing so far is the browser looks at how big the viewport is, how big the window is. But most of the time your images are not going to be 100% of the viewport. Well, the answer is you're going to provide another attribute called the sizes attribute. Now the sizes attribute is another comma-separated list, and each of these items is going to provide two pieces of information. First, the width of the window, This is kind of like a media query. It's like a minimal media query. You can use min width and max width in here. And second, you're going to provide the width that this image will display in that media query. And then last of all, you'll provide a fallback default width when none of the above conditions match. And the way the browser is going to do this is it's going to use the first condition that matches. So it's going to work from the top down. So the first thing that happens with this sizes array is the browser says, okay, is the viewport at least 1023 pixels wide? If the answer is yes, then it knows the image is going to be 780 pixels wide. So it'll look at the source set array and it'll pick the best image for that, which is probably this 960 one. On the other hand, if the browser is not 1023 pixels wide, then it'll go down to the next media query and it'll say, okay, is the browser window at least 675 pixels wide? If so, then the image is 620. Go pick the best asset. If neither of those conditions match, it'll land on the final condition, which is 100 VW. So what we're seeing here is a media query that describes that this image is going to be full width until 675 pixels, and then it's going to be 620, and then at 1023 it's going to go up to 780. So at this screen size, I will be displayed at this size, and you can choose from any of these images, which are this wide. So please pick the best image for right now. Now there's one last feature of responsive images that I'd like to talk about, which is what if we want different image crops per breakpoint? A site that I recently worked on had an interesting setup where they provided a hero image, but that hero image had a fixed height and the aspect ratio changed. So if I provided a 16:9 aspect ratio image and just gave a standard source set array, at the smallest screen sizes, over half of the pixels the browser would be downloading would be wasted. They'd be clipped off to the left and right side. So what we ended up deciding in this case, to keep things simple, was we provided two aspect ratios, square for small screens and 16:9 for large screens. And the way we did that was by using a new element called the picture element. Now the picture element contains sources, so it contains a source element, and it will always contain one of those source elements will be a regular image tag. Once again, this is the progressive enhancement acting here. If a browser doesn't understand the picture element, it will completely ignore the picture tag, it will completely ignore the source tag, but it will understand the image tag. But for browsers that do understand responsive images, what will happen here is it will see a picture and it will look at each of the sources and look at the conditions that they provide. So this first source element has a media attribute that has one of those media queries in it. It says max width 380. So if this query matches, use this source set array. Otherwise, use this one. So in this case, what we've said is on small screens, here's a source set array that happens to contain square images. And on larger screens, here's a source set array that contains 16:9 aspect ratio images. So this use case is called art direction. If you're only ever changing the size of the image, you're never changing the crop or the content of the image, you don't need to do this. But if you ever need to change the aspect ratio or the crop of the image at different breakpoints, keep this technique in mind. There's also one other thing you can do with the picture element, which is we can support new image file types. You may have heard that Chrome supports a new image format called WebP. I believe IE supports one called like JPEG 2000. Like there's a few of these floating out there. If you're in a situation where you can provide these new image file types, you can benefit from the abilities that they have, and still provide a fallback image for browsers that don't understand it. So it works the same way. We've got a picture element, which contains source elements, but instead of a media query on the source element, this time we're going to provide a type attribute. And it contains one of those MIME types. So it says, in this case, if type WebP is supported, then use this source set array. Otherwise, fall back to these source sets. So for browsers that understand it, they can benefit from WebP. For browsers that don't understand it, they'll fall back to the standard PNG image. No problem. So what about browser support? Well, luckily, browser support is phenomenal. Opera Mini and IE don't understand responsive images. Everyone else does. So again, because of that progressive enhancement, because of that backwards compatibility, I say there's no reason for you to hesitate to use this. This is a clear performance win. By using responsive images, you can ensure that users on small screens are not downloading images that are larger than they need. Users on large screens are getting a nice high quality image. Users on Retina are getting Retina, but you're not forcing Retina assets to users that don't need them. This is a clear usability and performance win for everyone, and there's no downside because IE will just keep getting the images you're already providing it today as the fallback. So cannot recommend this strongly enough. If you'd like to learn any more, this presentation is based strongly on 3 blog posts that I really like and recommend. A lot of the images in this post are by Eric Portis. They're from his post back in 2014 about source set and sizes. Jason Grigsby wrote a phenomenally thorough responsive images overview over on the Cloud 4 blog. And Jake Archibald wrote a really good breakdown of how the new elements of responsive images work. That is great for kind of understanding how these things interact. So I hope this was helpful. Thank you for your time.